Number 24 asks you to find the inverse of a function. They give you f of x equals 145 plus 12.5x. Remember that f of x is like your y. So step one, switch your x, and I put in quotes y, so switch x and f of x. I change it to a y just while I do the problem because it's easier to use than f of x. So my new problem will be x equals 145 plus 12.5 y. So we're just using the y long enough to do the problem. We'll switch it back when we're done. Step two is to solve for the y. We want to get it back into y equals equation or function. So I'm going to solve for y now the way you would a regular algebra problem. Subtract 145 from both sides. X minus 145, those cancel, equal 12.5 y. To move 12.5, divide that from both sides. So those cancel. You can separate this and write x over 12.5 minus 145 over 12.5, or you can leave it like that. If I was going to graph it, I would separate it because then I would have the slope and a y-intercept and it would be easier to graph. But they didn't ask me to graph it, so I'm not going to make extra work for myself. I'm going to leave it like that. When you go to write your final answer, you need to switch back to function notation. So I'm going to switch back to f of x, and to show that it's an inverse, we write f prime of x equals, this is our inverse function now, x minus 145 over 12.5. The second example is number 26. It's a graph. They ask us to graph this function and its inverse. I'm going to do it on the same graph, and we'll go over once again how to tell and make sure when you're done graphing that they really do look like they are inverses. So this is a linear equation. It's x to the first power. It's going to be a straight line. To find my m and my b, my slope and my y-intercept, I'm going to distribute the 4/5 through. Get 4/5 x minus 12. My y-intercept is negative 12. My slope is 4 over 5. So I'm going to count down 12. I'm going to count by threes. So 3, 6, 9, 12. And I'm going to write a point down here and give myself a little reminder of what that point was. So that ordered pair is 0, negative 12. And I'm going to do that because it'll make it easier to graph my inverse if I actually have the coordinates. So from there, I'm going to count my slope. Rise over run. I'm going to go up 4 and to the right 5. Up because 4 is positive, right because 5 is positive. Remember, I was counting by threes. So when I go up a dash, that's 3, and then 4 would be one more, and then to the right 5. So if I'm over 5, now that coordinate is 5. And I was down 12, but I went up 4 from there. So negative 12 up 4 is now negative 8. 2 points is enough to graph my line. So graph your line. Now for your inverse, you could go like we did on number 24, and we could find the inverse of this equation and graph that. Or what I would do is I would graph it as an inverse. So when we graph inverses, we switch the ordered pairs. So instead of 5, negative 8, I'm now going to switch that ordered pair for the inverse and graph negative 8, 5. The x and the y coordinates trade places. So 3, 6, negative 8 would be about right there, and then 3, 5. Instead of 0, negative 12, I'm going to flip, so it's negative 12, 0. And then we're going to graph that line. And it's a little bit difficult to tell for this one because they don't really intersect. But remember to check to see if your graphs look like you did them right. I didn't use graph paper, but to see if you think that you did them right, draw that diagonal line through the origin. That is the line y equals x. If you graphed them correctly, they should be symmetric to the line y equals x. So you should be able to fold one over onto the other one.